All right, so we just got done talking about how we have to be careful about what quadrant we end up in, how our angles look. But one thing I kind of want to show you guys, but then I'm already going to sort of do something else. Go ahead and write down this example here, please. All right, so Aaron did a lot of stuff, right? Aaron walked all over the place. So what we have to do is sort of draw this out. And so on this piece of paper that I have right here, it's just a blank piece of paper right now, I'm going to put a little box. First of all, Aaron walks east, north, south. Okay, so how he's going. I'm going to start my box in this bottom corner over here for where Aaron starts. Okay, I'm going to put an X marks the spot for where he starts. I even have some markers here at home, so I'm going to put that in a box, right? So that's where Aaron starts. He first walked 8 meters, so that's kind of a long line. He walked 8 meters towards the east. Okay. He then walked 6 north. 4 north. He then walked 6 more east. Okay, hopefully that one's a little bit shorter than your 8. He then walked 9 north. Okay, that's a long one. It might go near the top of my paper. But then he walked 3 south. All right, and I kind of overlapped that one like I did the other day a little bit. So here's the deal. Where did Aaron start? Right, where I put that big box. Where did Aaron end? And so what I would want to do is make one vector that goes from where he started to where he ended. Now, is this a straight line? Then we would need to use a right triangle to solve it, okay? And we're just going to kind of go through this because how many people agree that it kind of, even though my line is too long, it kind of looks like Aaron went to the right and up. Okay, so my line to the right I made a little bit too long just so I could kind of show it, and then up stops there. So the way I do this, I would get a right angle. Technically this marker is pink. It might look kind of reddish, whatever. I don't really care. Would anybody like to tell me what we could figure out about this line across the bottom? Yeah, it went 8, and then it also went 6. 8 plus 6 is 14. So Aaron's length to the right is really 14, even though he only went 8 first, then 4 something else, and then 6. He went 14. What about this vertical line? Oh yeah, he went up 4. He went up 9 more. That's 13. But then he came back 3. So this would be 10. Guys, before we could do anything else with this, we would have to pretend that Aaron walked 14 to the right and 10 up. And now we would be able to use Pythagorean's theorem and SOHCAHTOA, TOA most likely to find the theta. Yes, I purposely made this be in quadrant 1. So ladies and gentlemen, unlike we talked about on our Google Meet a few minutes ago, once you find theta here, theta is your answer because you are comparing it to 0 degrees. Because would you agree to this line to the right is 0, and 0 degrees begins by going up, right? And that's what we were talking about on Google Meet. And so 0 degrees going up would match that theta. You know, that's kind of a lot of work. And there are some types of math where that's the type of work you need to do. Because people go on like little treasure chests and things like that. Treasure hunts. And maybe they find their treasure and they're like, as soon as you get done, come back to X marks the spot. So they had to go here, 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 here. And they know when they're done, they don't want to walk back all those ways. They might want to just run across the field right back to where the spot is. So today we're going to learn something that is a part of math. Okay, what we were doing yesterday is also a part of math. It's actually a visual, sort of physical part of math. Our lesson today, 8.2, is called vector notation. Okay, so I'm going to put up a drawing here. You do not need to make this drawing in your notebook, okay? But I made an XY scale down here. I made it kind of big so we could all see it okay. I know it's written in pen, but if you look on here, I have a whole bunch of vectors, right? They have the black dots where they start, and they have the arrowheads where they end. So if we look at these, all of these vectors, now is there anything you would like to tell me about these vectors? Thank you. They all look the same. The easiest one to figure out is the first one, the one I based at 0, 0. So if you look at 0, 0, would you agree I went 3 steps to the right and then 2 steps up? So this arrow is going right and up. And I know some people might say, well, why don't you say upright? Because think about X, we always do first. Y, we always do second. So would you agree that we went 3 to the right and 2 up for that first vector? Perfect. Well, what about this one? Even though we started here, 1, 2, 3, 1, 2. These vectors are the same. They just started in a different spot. And guys, this would honestly be right now in class when I would say, all right, everybody, we need to be a little bit active. People are falling asleep. Everybody stand up in your desk. And I would start to play the cha-cha slide. And we would like, to the right, right. Everybody would do the same thing. And the thing is, if all of a sudden I would pause the music, most likely our class configuration would be the same. Meaning Aaliyah and Aaron would still be sitting right in the same spot, right next to each other. They maybe just shifted over or had moved forward or moved to the left. It all kind of depends on what part. And I know some of you are right up against like an area where you couldn't move, pretend we had unrestricted things. Okay? Some basketball teams do this with the coach at the front and they're going like this and this and this and this. And you see them and they point forwards and backwards and this way and that way. And you see the whole team move as a collective and they stay together, evenly spaced out and don't really overlap or go across each other. Okay? So same thing right here. This person started here but was asked to move 3 to the right and 2 up. This person started here, was asked to move 3 to the right and 2 up. All of these vectors have components of 3 to the right and 2 up. So since all of these vectors have components of 3 to the right and 2 up, maybe there should be a way we could actually write this out. And so I am about to teach you what vector notation looks like, okay? Normally, if I just wanted to put a dot right here, like if I just put a big fat dot right here, you would label that as the point, and I know you didn't know where I put it, 4, 2, but you would put it in parentheses so people knew that it was an ordered pair and it represented 1 dot on our graph. Because vectors are this entire line because they have a size and a direction, we are not going to put our vectors in parentheses. It kind of looks like the greater than, less than signs. All right, so you will put vector notation by putting those brackets like that instead. They are still separated by a comma. But your horizontal component goes first and your vertical component goes second. And so we will know which way we go horizontally by what is right there. We will know how many we go vertically by what is right there. So let's think about this. What if every single one of these vectors right here was represented by 3 to the right and 2 up? It doesn't matter where we start. Every single one of those vectors would be written as 3, 2, but instead of being in parentheses, they would be in those vector notation brackets, okay? So when we write something like that, it is a vector. Just so we know, I could have you guys repeat a vector. Like on the first thing we did this morning where we didn't really finish solving it, Aaron went 8 to the right. What if I would say again, Aaron went 8 to the right, Aaron went 8 to the right, Aaron went 8 to the right. I just said it 3 times, so he didn't really go 8 to the right. 3 times 8 is, yeah, he went 24. So same thing, I could repeat a vector. So sorry, I already had the answer because they're not hard. What if I said, hey, go once, but go twice? How many really did we go to the right? 6. How many really did we go up? 4. Guys, that's the same thing as doubling. So what if I just put a 2 in front here? It is very, very, very much like distribution. And we can do that because these are not ordered pairs. This is a vector. And this was saying go 3 to the right, but I want to go twice that. So twice 3 to the right would be 6. Twice 2 would be 4. All right, so just so we know, that gives us our size and direction because that tells us the vector is 3 to the right and 2 up. The reason we know it's to the right is because it is positive. Thank you. The reason we know it's up, positive. So just a quick little reminder, but we should know this anyway. If you go to the right, your number should be positive. If you go to the left, your number should be negative. If you go up, positive, down, negative. So the example we've been looking at so far has been 3, 2, which is right and up. I know a lot of people want to say like, oh, we went up and then right. But again, we always do our horizontal first and then our vertical second. So we go up and to the right. The next example I have right there would be 4, -8, which would mean we would be going to the right and down. And guys, right now, the third example I have right here is -6, -6. Hey, I know we did some examples together, but here's what else you have to do today. Because I want you watching this video and kind of checking in and making sure that it makes sense. Do you see how I have 2 blanks right here? Obviously, I want you to fill them in on your notes, but I need you to pause your video right now. Go back over to the Google Meet, turn on the Google Meet and say, hey, Miss Jabs, and everybody might be at a different time. You might come in Google Meet and there might be 4 other people there. You might come in Google Meet and you might be the only person there. But, excuse me, you're gonna click back to the Google Meet right now and say, hey, Miss Jabs, I'm to the first checkpoint. And the first checkpoint was to tell you, how did this vector go? And I think this vector goes, okay, that's what you told me on Google Meet. So you paused the video, went to Google Meet, you're back at the video. Guys, the other day I had a whole bunch of people, like Nehemiah was the first, no, Nehemiah didn't do anything. He just ran 5 miles. Whoever my first person in the example was or on the homework was, I said something like, they did this, then they did this, then they did this. And we had to worry about where they went. And when it was a triangle, especially if it was errands, we would need to worry about one right triangle and do a lot of math to figure that out. When we write things in vector notation, our math is going to go a lot faster. Because remember, the first thing is always a vertical, is always the horizontal component. And the second thing is always the vertical component. So we are going to combine our horizontal components. We are going to combine our vertical components and we're going to be done. So I have a whole bunch of examples here. I started to write some of the answers and fill in the blanks, sort of. But you might want to pause and write all these down, and then I'm going to put the paper down and talk through what you should do. So write all these examples down. All right, number 1. If we look at it, what is our first horizontal component? 2. What is our next horizontal component? 6. So we're going to take 2 plus 6, which is 8. That means we really moved 8 to the right. Even though we did the first one and then the second one, we moved 8 to the right. 8 plus -3. Ooh, negative. Yep, you can kind of subtract. So 8 minus 3 is 5. The answer for example 1 would very simply be 8, 5. Done. You don't have to figure out an angle because it's already telling you that this is going right up. Second example, -6 plus 4. -2. -4 plus 4, 0. You can get an answer of 0. If we get a vector like this, this is telling us we are only going to the left. So on my scale, I would just have an arrow going straight to the left. It wouldn't be like going up or going down. It would just be going straight to the left. So -2, 0. You do have to put that 0 there because it's very much like an ordered pair. All right, so guys, just a second ago I said like we could double things, we could do stuff like that. First, please take 4 times the amount. So what's 4 times 1? Thank you. What's 4 times 3? Very nice. Also distribute that 2. What's 2 times 8? Very good. What's 2 times -1? All right, I know I haven't held my paper up, but I basically told you what to do. The last thing you have to do is combine the horizontal components and the vertical components. So once again, I know I just had a checkpoint a few seconds ago. These last few checkpoints are going to go pretty quick. So if you would pause the video again, come over and say, hey, Miss Jabs, I'm on example 3. I was supposed to come back to the Google Meet, and here's the answer when I added those 2 vectors together. All right, so I told you to go back to the video, start playing again. You might have looked at that last example and said they were all added. Can I subtract? Yes, you can. You can subtract vectors. All you have to do is subtract. Hello, I mean, that makes sense. 8 minus 3, Sorry, I didn't hold that up long enough. Go back and pause if you need to. Okay? 8 minus 3. 2 minus 5. 5, negative 3 is that answer. Guess what we should do first on this one? Distribute. I'm going to do this one fully with you on the video. 3 times 8 is 24. 3 times 5 is 15. All right. Ladies and gentlemen, there are 2 things we could do on this next one, but you need to be careful. I could distribute a negative 6 if I would want, but if I distribute a negative 6, I am pretending that that negative goes with the 6, and so the negatives should disappear, meaning I am going to change this to a plus on this problem. What is negative 6 times 1? Negative 6. What is negative 6 times 3? Negative 18. Please listen. Because I distributed the negative 6, this becomes positive. If you would want, guys, it really would be okay for you to think, well, this was a subtraction problem. Shouldn't it say subtraction? If it stays subtraction, you're just going to distribute the 6. What is 6 times 1? What is 6 times 3? Please listen. Either one of these is okay, but it would not be okay if you would have distributed the negative 6 and still had subtraction. Either way, you're going to get 24 minus 6, which is 18. 15 minus 18, which is negative 3. Either way you would do this work, you should get 18, negative 3. All right, so just a few last things I need to cover. Because what if I would want to reuse one of those vectors? Or what if all day today we are working with something and I'm like, hey guys, this is what we always have to do. And there are some things, I don't know if any of you in art class have worked with vectors, but there is some vector stuff that sometimes when you're doing work in a computer class, you need to have it in like a vector mode instead. But if we look at this, we can actually name vectors, okay? So vectors are named by lowercase letters. And so we would start out with A. But so that we knew A was not just a variable, you put this little sort of directional thing on there. That is a mathematical symbol to mean vector. So A with this little sort of half ray type thing over the top of it actually means vector. This would stand for vector A. Sometimes when you do it, it's bolded. Sometimes it's kind of italicized, but vector A would be represented like that. So I have a few vectors. Go ahead and pause. I have a few vectors labeled right here. Go ahead and pause and write these in your notes. Because now I could do like, hey guys, example number 6. What should we do if we want to add A plus B? Oh yeah, we would look back up here. And we would want to do vector A, which was my 1, 3, plus vector B, which was my negative 4, 4. Remember, we called A and B up here. So A plus B would be, thank you, negative 3, 7. Pretty easy? Good. What would we do if we had, these next two lines kind of look confusing, but don't let yourself get too confused. Keep this coefficient of a 3 here. We are going to make C 3 times bigger. But C was 7, negative 5. So before I move on too much, what's 3 times 7? What's 3 times negative 5? Next, I am going to have to subtract D. But I don't have to make D 2 or 3 times bigger or anything like that. So I'm just going to write minus 3, 5. And I'm going to copy that right on down. And now I have to make B 3 times bigger. Well, B was my 4, 4. So what's 3 times negative 4? And then what's 3 times positive 4? So now I have these, but guys, remember, all of these first things are my horizontal components. So this would sort of be like, hey, move 21 to the right, but now move back 3, and now move back 12. So we're just going to do it in the order that we read it. What is 21 minus 3? That would be 18, plus a negative 12 18, technically just minus 12 would be 6. Negative 15, I'm doing verticals now. That would sort of be down 15, down 5 more, that's 20. But now I got to go up 12, so that would be negative 8. Right? Because we went negative 15 minus 5 more, negative 20 plus 12 is negative 8. So your answer for that one would be vector components. And we leave the answer in those vectors. And by the way, this is saying it's a vector that goes to the right and down. And so again, it tells us our size and direction. So last checkpoint to check back in with me and say, hey, Miss Jabs, I'm to the end of the video, but I was supposed to work on example 8. We could do a whole bunch of adding, and since I gave you 4 vectors, would you please add vector A, B, C, and D? Please do that before you click back to the Google Meet. Come back to the Google Meet and say, hey, Miss Jabs, I'm to the end of the video. The answer for example 8 is this. Guys, I think, and this is kind of the funny thing, the first day we did vectors made a lot of sense, but it's a lot of work. This is a very simplified type of math work, and like we said before, every time we do a part of math, there is a major of math and a type of math that only works with this part of vector stuff, not the stuff we dealt with yesterday. So the rest of the chapter, we're dealing with these vector component stuff. So please make sure they're making sense. Come check in with me on checkpoint example number 8. Not checkpoint number 8, but example number 8, and let me know you're ready. And the homework should be posted and ready to go very, very soon here. Thank you. Have a good day and weekend.